Nomenclature is naming compounds. In general, you could categorize it into two types. Ionic compounds are made from a metal plus a nonmetal. The metal loses electrons, in which the nonmetal will accept or take. Ionic compounds may also consist of polyatomics. Covalent compounds are between nonmetal and nonmetal, and they are sharing electrons. The easiest of the nomenclature is fixed ionic compounds. So it's between a metal and a nonmetal. When we are talking about fixed ionic compounds, we are talking about fixed charges. The metals are usually from group 1, 2, 3, and ammonium, which is a polyatomic, NH4+, and nonmetals, which are from group 5, 6, 7, and negative polyatomics. From the parts of the periodic table lecture, we learned that group 1 has a charge of 1 plus or plus 1. Atoms in general want to fulfill the octet rule. They want to have 8 valence electrons. Since group 1 has 1 valence electron, it is easier to lose that 1 valence electron than take in 7 to make 8. Group 2 has 2 valence electrons, so it tends to lose the 2 rather than take in 6 to make 8. Group 3, which is boron family, has 3 valence electrons. It's easier for it to lose 3 than take in 5 to make 8. Carbon family has 4, so it can take or give away 4, so it tends to be a plus or minus 4. Nitrogen family has 5 valence electrons. At this point, it's easier to take in 3 electrons to make 5 rather than get rid of 5 valence electrons. So it has a minus 3 charge. Remember, only electrons move. So when you gain electrons, you're going to have more electrons which are negative in charge. When you lose electrons, you're going to have less negative charge because there's less electrons, so there's more positive charge. Oxygen family has 6 valence electrons. It's easier to gain 2 rather than get rid of the 6 valence electrons. So it has a charge of minus 2. The halogen has 7 valence electrons. It's easier to take in 1 than get rid of the 7, so it has a minus 1 charge. And we know group 18, the noble gas, do not have any charge. The general rules for writing fixed ionic compounds from name to symbol is 1. Find the symbol and charge of the metal. 2. Find the symbol and charge of the nonmetal or polyatomic. 3. Reduce. 4. Crisscross down. 5. Use parentheses for more than one polyatomic. For this class, all the polyatomics will be negative in charge, except for one, which is ammonium, which is NH4, will behave like a metal. For ionic compounds, the first element is always a metal. So francium is a metal found in group 1. The symbol for francium is Fr. The charge is 1. We don't care about the plus or minus. We just want the number. Oxygen or oxide is the nonmetal. So we're going to find the symbol, which is O. The charge is 2. Next step, we need to reduce. 1 and 2 are not reducible, so we leave it as is. Next step, we're going to crisscross. The 2 from the oxygen will come down to the francium. The 1 from the francium will come down to the oxygen. So if we rewrite this, this is Fr2O1. We do not write 1 for the subscript, so this becomes Fr2O. That is the symbol for francium oxide. We will initially be working with neutral compounds. To make the compound neutral, the positive and negative charges must cancel out. So francium, there are 2 francium. The subscript tells you there are 2 francium. The charge of francium is 1 plus. There is 1 oxygen. The charge of oxygen is 2 minus. If I add this up, the overall charge of the compound is 0. And we want all the compounds right now to equal to 0. So when we crisscross the charges down, this tells you how many of that element is needed to make the compound neutral. Strontium chloride. This is also an ionic compound because the first element is a metal. So we look up the symbol and charge. Sr, the charge is 2. The nonmetal is chlorine or chloride. Symbol Cl, charge is 1. 2 and 1 cannot be reduced any further. Now we must crisscross down. The 2 comes down here. The 1 comes to the strontium. So Sr, 1. Cl2, again, we don't write the 1, so it's Sr, Cl2. And if you notice, this is also neutral. We could check. There is 1 strontium. The charge of strontium is 2 plus. Plus, there are 2 chlorines. The charge is minus 1. That equals to 0. Magnesium nitrate. Magnesium symbol is Mg. It has a charge of 2 plus. Nitride or nitrogen is capital N with a charge of 3 minus. Now we reduce. 2 and 3 are not reducible. Now I crisscross down. The 2 from the magnesium comes to the nitrogen. The 3 from the nitrogen comes to the magnesium. So the correct formula for magnesium nitride is Mg3N2. We could recheck if it's balanced. 3 Mgs. The charge of Mg is 2 plus. There are 2 nitrogens. The charge of nitrogen is 3 minus, which equals to 0. Sodium acetate. Sodium is Na. Charge is 1. It's in group 1. Acetate, anything that ends in an 8 or an ite is a polyatomic. So it's C2H3O2. This is a 1. It cannot be reduced, so it's just NaC2H3O2. Ammonia is the only positive polyatomic, that is NH4 plus. Bisulfate is the same thing as hydrogen sulfate. You do not have to memorize this. I will provide it on the quiz if it's on your quiz. And that is HSO4 minus. So it's 1 to 1. So there's no reducing. So it's just NH4 HSO4. And we do not reduce these. They stay as is. Cesium, CS, charge is 1. Carbonate, again, a polyatomic. It ends in 8. CO3, 2 minus, cannot be reduced. The 2 from the carbonate goes to cesium. The 1 from the cesium goes to the carbonate. So it's CS2CO3. Silver cyanide. Silver is one of the transition metals that have a fixed charge. So you need to memorize it. It's plus 1. So silver is 1. Cyanide is one of the few exceptions that is a polyatomic that ends in IDE. Remember, your polyatomics in general end in 8 or ite, but cyanide is an exception. Cyanide is CN, charge is 1. Since it's not reducible, it's just AgCN. Barium is Ba, charge of 2. Hydroxide is, again, one of those exceptions. Hydroxide is OH, charge is 1, cannot be reduced. Now we need to crisscross down. The 2 from the barium goes to the hydroxide. The 1 from the hydroxide goes to the barium. So it's Ba1, which we don't write the 1. Since there is more than one polyatomic, we need to do OH in parentheses 2. And we could check if this is correct. There is 1 barium. Charge of barium is 2 plus. There are 2 hydroxide ions. The charge is -1. And if I add this up, this is equal to 0. So for more than one polyatomic, you always add a parentheses. Aluminum, Al, charge is 3. Izide, again, this is another exception to the polyatomic. It ends in IDE. It is N3, charge is 1. We cannot reduce the 3 and 1. The 3 from the aluminum goes down to the izide, and the 1 from the nitrogen goes to the aluminum. So this is Al1, which we don't write, parentheses N3, parentheses 3. Remember, izide is a polyatomic. There is more than one polyatomic. So we put a parentheses and a 3 on the outside. Now we're going to go from symbol to name. First, we're going to find the name of the metal and write the name as is. There is only one polyatomic that is positive, that is ammonium, NH4 plus. Number 2, find the name of the nonmetal, drop the ending, and add IDE. For polyatomics, we write the name as is. So whatever the name is on your polyatomic sheet, we just copy it as is. So GaCl4. Ga is a metal in boron family. It is gallium. So we write the name as is. Cl is a nonmetal. It is chlorine. So it's chlorine. We drop the ending and add IDE. So it's gallium chloride. We ignore the subscripts. Next one, Sr parentheses OH parentheses 2. Sr is a metal. It is strontium. OH is a polyatomic. Polyatomic is an ion with more than one atom. So OH is a polyatomic hydroxide. We ignore the 2 subscript. NH4 is a polyatomic. It's ammonium. The nonmetal is oxygen. Drop the ending and it becomes oxide. Again, we ignore the subscript. KH2PO4. K is a metal, potassium. In group 1, we write the name as is. H2PO4 is a polyatomic. It is dihydrogen phosphate. It is off your polyatomic chart. Magnesium. Mg parentheses ClO4 parentheses 2. Mg is magnesium. Write the name as is. ClO4 is a polyatomic. So it's perchlorate. We ignore the subscript. Al2 parentheses Cr2O7 parentheses 3. Aluminum. We ignore the subscript. Cr2O7 is a polyatomic dichromate. We ignore this parentheses. We ignore this subscript. This subscript 3 just tells you I need 3 dichromate to make this compound neutral. CD3P2, this is cadmium. The nonmetal is phosphorus. Drop the ending, so it's phosphoride. Phosphoride. Drop the ending, add IDE. If you notice, we ignore the subscript. Ca is a metal, calcium. In group 2. Polyatomic, CO3, carbonate. Zn is one of those transition metals that you have to memorize because it's fixed. That's zinc. This is a polyatomic. Sulfite. Sulfite, not 8. 8 is a 4, ite is a 3. Ites and ates differ by 1 oxygen. Rb is rubidium. HCO3 is a polyatomic. It is hydrogen carbonate, also known as bicarbonate. Either or is correct. Remember, I will provide you with all the polyatomics. Fixed ionics are from groups 1, 2, and 3, and ammonium for the metals. The nonmetals are on the right of the zigzag line and polyatomics. In addition, you need to memorize the charges for silver, which is a +1, cadmium, which is a +2, and zinc, which is a +2.